Hello, this is Dr. Brown, and in this lesson 9.1, we're going to look at solving application problems using what we've learned about right triangles. The main objectives are, number one, to be able to solve right triangle problems, and then to solve particular practical problems using what we know about right triangles. Solving right triangles. First of all, we need to remember the Pythagorean theorem that given a right triangle, that c squared is equal to a squared plus b squared, and that also the two angles other than the 90-degree right triangle have to add up to be 90 degrees. So a plus b is 90 degrees. Here's a very simple triangle problem we're going to solve. We're given a right triangle with an angle of 40 degrees for angle A, and we want to find angle B. And we're given that one side is 2, so we want to find the other two sides. We quickly realize that 2 over c is going to be equal to sine of b. And notice that b will be 50 degrees. Subtract 40 from 90. So 2 over c is equal to sine of 50 degrees. And cross multiplying, we get sine of 50 degrees times c equal 2. And c is equal to 2 over sine of 50 degrees. And that is 2.6108. Then to solve for a, we can notice that 2 over a is equal to tangent of 50 degrees. And so a is equal to 2 over tangent of 50 degrees equals 1.6781. Now, next problem, we got a right triangle in which we're given two sides, and we want to find the other two angles plus the hypotenuse. So the first thing we do is use the Pythagorean theorem to find c. c is equal to a squared plus b squared, with a equal 3 and b equal 2. That's 3 plus 4 equal 13. And so c is the square root of 13, which is 3.61. To find angle A, we will use the fact that tangent of A is equal to 3/2. So A is equal to inverse tangent of 3/2. Now, we're going to show you how to do this very quickly. First, since we're working in degrees, we need to be sure that we are in the degree mode. In this particular case, we had worked a problem in the radian mode, so we put it back into the degree mode. And then calculate inverse tangent of 3/2. Well, you got to put inverse tangent of 3/2 in. Evidently it didn't take the 2. So inverse tangent of 3 halves should give us that the angle is 56.309 degrees, or rounded off to 56.3 degrees. Now, notice that in order to get B, that B is going to be 90 minus 56.3, which is 33.7 degrees. Now we're going to solve some applied problems. We've got a long hill here that starts at an elevation of 8,000 feet and goes up to an elevation of 11,100 feet. So obviously the amount that you have gone up vertically is 3,100 feet. So drawing a triangle in which the hypotenuse is the top of the hill, or as you walk up, we want to find out what the inclination or the steepness of the grade is in degrees. So labeling this angle B, we get that sine of B is equal to 3,100 divided by 14,100, which is the hypotenuse. And so B is equal to the inverse sine of 3,100 over 14,100, which is 12.7 degrees. I'll assume you stop the video and show yourself that you could do this particular problem. Now, we're going to look at over the horizon kind of problem. There's a lighthouse in Southampton, Bermuda, that's 362 feet high. And it's 117 feet high on a hill, 245 feet high, which makes it the top of the lighthouse 362 feet above sea level. A brochure states that the light can be seen on the horizon about 26 miles distant. We want to see if that's accurate. Now, drawing an arc of the earth, with this point being the center of the earth, and the earth being about 960 miles in radius. And if we look at the top of the lighthouse and figure out just how far someone at the lighthouse could see, you draw a line that just touches the earth, and this would be a 90-degree angle. So now we have a right triangle with a base of 3960 and a hypotenuse of 3960 plus 362 divided by 5,280, which would be convert 362 feet to miles. So cosine of angle theta is equal to 3960 divided by the hypotenuse, which is 3960 plus 362 over 5,280. And you need to carry this out to a lot of decimal places. That cosine of theta is equal to this number. Therefore, theta is equal to the inverse cosine of 0.99, which is equal to 33715 degrees, which if you convert to radians, or either you could have had your calculator in the radian mode, you would have gotten that the angle theta is 0.00588 radians. That means that the arc length subtended by the angle theta is equal to 3960 times the angle theta in radians, which would be 23.3 miles. That means that somebody that's beyond 23.3 miles could not be seen by the lighthouse. And you could also say that somebody that's beyond 23.3 miles could not see the lighthouse. So the statement that you can see the lighthouse if you're 26 miles away is not quite accurate. Now we're going to look at some ways we describe angles when we're talking about going in various directions around the earth. Looking at your directions of north, south, west, and east. Point 1, if it is 30 degrees towards the east from north, the bearing we would give it is north 30 degrees east, which means you're going to the north, but 30 degrees towards the east. Point P2, if it's 50 degrees away from due south, you would say you were south 50 degrees towards the west. And then, if you're point 3, that's 70 degrees from a northerly direction. You would say the bearing is north 70 degrees west. That's 70 degrees towards the west from north. And I'm going to ask you to write down for point 4 what you think the bearing should be. So think about it, and we'll see it on the next slide. Write down what the bearing would be here. Well, obviously, it's going to be towards the south, 20 degrees east. So the bearing would be south 20 degrees east. Now here's an example we want to work. We want to find the bearing of an airplane. It takes off from Nashville International Airport and goes on a bearing of 20 degrees north, 20 degrees east. So it takes off in this direction, 20 degrees towards the east, away from the north. And after flying for 1 mile, request permissions to turn 90 degrees and head towards the northwest. The request is granted, and after the plane goes 2 miles, in this new direction, what bearing should the control tower use to locate the aircraft? So, drawing a triangle here, we have side 2, side 1, and we want to know what the bearing should be. First of all, we should figure out what angle theta is. And notice that tangent of theta equals 2. So theta is equal to inverse tangent of 2 degrees, which is 63.4 degrees. Now notice that angle, which is 63.4 degrees, we can subtract 20 degrees, and then that would give us a bearing in our new direction. So take 20 degrees from 63.4 degrees, which is 43.4 degrees. So the bearing, is going to be north 43.4 degrees towards the west. And that is the lesson for today.